Precipitation. It's something we all experience, yet its complexity often goes unnoticed. Whether it's a gentle rain, a heavy snowstorm, or a sudden hailstorm, precipitation plays a crucial role in Earth's water cycle. In this video, we'll explore the various types of precipitation, how it's measured, and the factors that influence it. We'll also take a global look at precipitation patterns and understand how climate change is affecting them. Let's start with the basics. What is precipitation? Precipitation is any form of water that falls from clouds and reaches the ground, but not all precipitation is created equal. The most common forms are rain, snow, sleet, and hail, each of which forms under different conditions. But what differentiates these forms? Rain occurs when water vapor in the air condenses into tiny droplets, which come together to form larger droplets. When these droplets grow too heavy for the air to support them, they fall as rain. Depending on temperature and air currents, rain can range from a light drizzle to a torrential downpour. Snow, on the other hand, forms when temperatures are low enough that water vapor turns directly into ice crystals. These crystals then join together to create snowflakes. But what about sleet and hail? Sleet forms when raindrops freeze before they hit the ground, creating small ice pellets. Hail is formed in storm clouds with strong updrafts that push raindrops upward into freezing regions of the cloud, where layers of ice form around the droplet. Eventually, these ice balls, called hailstones, become heavy enough to fall to the ground. Hail can range in size from small pebbles to large stones capable of causing significant damage. These different forms of precipitation depend heavily on the temperature and atmospheric conditions. Understanding the different types of precipitation is important not only for predicting weather, but also for preparing for the impact these events can have on our daily lives, from agriculture to transportation. Now that we know what precipitation is, how do we measure it? Accurate measurement is crucial for weather forecasting, agriculture, and water resource management. There are three main tools for measuring precipitation: rain gauges, radar, and satellites. Rain gauges are the simplest and oldest tool. They collect rainwater, and by measuring the amount in the gauge, we can determine how much rain has fallen. While rain gauges provide precise local measurements, their coverage is limited to the areas where they are placed. Radar, on the other hand, is more sophisticated. It sends out radio waves that bounce off precipitation particles, allowing us to estimate the intensity and movement of rain or snow in real time. Radar is especially useful for tracking storms and severe weather events. You've probably seen radar imagery in weather forecasts, showing where storms are headed. Satellites offer a global perspective. They orbit the Earth, collecting data on cloud cover, rainfall, and even snowfall over vast areas, including the oceans, where ground-based measurements are impossible. Satellites help meteorologists observe large-scale weather patterns and predict phenomena like monsoons or hurricanes long before they reach land. The combination of rain gauges, radar, and satellite data gives us a complete picture of precipitation patterns worldwide. Precipitation doesn't fall equally everywhere. A variety of factors influence when, where, and how much precipitation occurs. One key factor is geography. For example, coastal regions tend to receive more rainfall due to the presence of large bodies of water. Warm air over the ocean picks up moisture, which rises and cools as it moves inland. This process leads to cloud formation and eventually, rainfall. In contrast, areas further inland may experience less precipitation due to the lack of moisture from the ocean. Mountain ranges also play a major role. When moist air is forced to rise over a mountain, it cools and releases moisture in the form of precipitation, known as orographic rainfall. The windward side of the mountain gets a lot of rain, while the leeward side often experiences a dry rain shadow effect. Atmospheric circulation patterns like the trade winds, jet streams, and pressure systems also play a major role. For instance, regions near the equator experience consistent rainfall due to the intertropical convergence zone, where warm air rises and condenses, leading to heavy rain. Finally, local weather systems, such as fronts and low-pressure systems, can trigger precipitation by forcing air to rise. When warm and cold air masses meet, the warmer air is pushed upward, leading to cloud formation and eventually, precipitation. Now let's look at global precipitation patterns. As we just discussed, geography and atmospheric circulation lead to significant differences in rainfall across the world. In tropical regions like the Amazon and Southeast Asia, rain is abundant due to warm temperatures and regular convection currents. These areas can receive more than 2,000 millimeters of rain a year. In contrast, desert regions such as the Sahara get less than 250 millimeters of rainfall annually, mainly due to dry air and high pressure that prevents cloud formation. Monsoons also play a critical role in global precipitation. In countries like India, the seasonal shift of wind patterns brings heavy rains that are vital for agriculture. Without the monsoon rains, entire economies could suffer due to drought. Finally, let's talk about how climate change is impacting precipitation patterns. The Earth's climate is warming, and as temperatures rise, the atmosphere can hold more moisture. This can cause flooding and damage to infrastructure, as we've seen in many parts of the world recently. At the same time, other regions are experiencing longer and more severe droughts, as warmer temperatures cause more evaporation and reduce available water sources. The result is a growing imbalance, with some regions receiving more water than they can handle, and others receiving far too little. The latest reports from the Intergovernmental Panel on Climate Change, IPCC, suggest that wet regions are becoming wetter, while dry regions are becoming drier. This is already affecting communities worldwide, from increasing flooding in coastal cities to more frequent droughts in agricultural regions. Understanding these shifts is crucial for future water resource management, agriculture, and disaster preparedness. It's not just about more or less rain, it's about where, when, and how that precipitation occurs. Precipitation is a key element of the water cycle, sustaining life on Earth. By understanding its types, how it's measured, and the factors that influence it, we gain valuable insights into the natural processes that shape our world. And with the growing impact of climate change, these insights are more important than ever. Stay tuned for our next video, where we'll explore how precipitation data is used in hydrological modeling to forecast water availability and manage our resources. Don't forget to like, share, and subscribe if you found this video helpful.